All right, today we're going to do lesson 8.4, and you can see by the lesson title, we are going to continue graphing and learning about what kind of a function. If you think back to last week in 8.1 through 8.3, what kind of a function are we learning how to graph and how to work with? If you can't remember, let's see you flipping back to lessons 8.1 to 8.3. Quadratic functions. Now, quadratic functions, when we graph them, what kind of a graph do they make? Okay, a parabola. That U-shaped graph is called a parabola. All right? And last week, we looked a lot at how to work with the standard form of a quadratic function. So somebody raise your hand and give me the quadratic standard form. Okay, give me the equation of a quadratic function that is in standard form. Again, you should look back 8.3. It was your flipped classroom last week, and it was right there typed in your notes for you.
X squared plus bx plus c.
All right, y equals, or f of x, it's the same thing, equals a x squared plus bx plus c. Now, we can see that is very different from the form that we're going to look at today, but I need you to understand they're both quadratic functions. They're just in different forms. So the essential question today is, how can you describe the graph of f of x equals a times x minus h squared? Now, before we get into graphing of this form, let's look at how we tell if a function is even or odd. Now, this is going to seem very complicated, but it's actually very simple. For both even and odds, we're going to go through and replace each x in the original problem with a negative x. Okay? Then we're going to simplify. We're going to follow our order of operations, and we're going to simplify these functions. Then we're going to check for sign changes. Okay? Does our new function match exactly our original function? If it does, then we have an even function. But what happens if we replace each x in the original problem with a negative x? And we look through for sign changes, and we see that our new function is the exact opposite of our original function. Well, that means that our function is an odd function. If it falls into neither of those categories, it's neither, okay? If it's not the exact same or the opposite of the original function, then it would fall into the category of neither. So let's practice it. Example number 1, determine if the function is odd, even, or neither. Now, I kept the first one really simple. So we have f of negative x, because that's what we're about to go do. We're about to go into the function, and everywhere we see an x, we're going to plug a negative x. So it equals 5, and we're going to plug that negative x in parentheses. Now, let's simplify this problem. What are we doing with 5 and negative x? We're multiplying them. So f of negative x equals, what is 5 times negative x? Negative 5x. Now, let's look at our new function, and let's compare it to the original function. What do you notice about our function and the original function? They're opposites, okay? It's not enough that they're different, it's that they are exact opposites of each other. So is this an even, an odd, or neither function?
Odd.
This is an odd, okay? If the original function and the new function are opposites of each other, it is an odd function. Now, letter B. We're going to take h of, again, negative x, because that's what we're plugging in, equals 2. Everywhere we see an x, we're plugging a negative x. Everything else about the function stays the same, though. So, according to our order of operations, what are we supposed to do first when we start simplifying this problem? We don't have parentheses. Exponents. Good. So, over to the side, let's just make sure we understand and remember. Negative x squared is negative x times what? Negative x. And what does negative x times negative x equal? Positive x squared. All right? So, when I simplify this function, h of negative x equals 2x squared plus 3. Now, let's compare our new function to our original function. And what do you notice about the two functions? They're exactly the same. So, even, odd, or neither? Even. If the new function and the original function are exactly the same, it is an even function. Now, when we move into the next section, we're talking about graphing functions that are in vertex form. So grab your highlighter. I want you to highlight vertex form, and then I want you to actually go and highlight the formula, which is right here. F of x equals a times x minus h squared plus k. Now, what you don't realize yet is that you're going to love vertex form. When these functions are in vertex form, you're going to be very happy because the vertex is the ordered pair hk and can be pulled straight out of the function. Now, if you remember standard form last week, we had to use the formula x equals negative b over 2a, negative b divided by 2a. Then once we found the x value, we had to plug it back into the original problem to find the y value, and then we had our vertex. Well, vertex form, it's there. We pull it straight out of the function, and we're done. Okay? So let's talk about what that means. If you notice the formula, I want it to stand out to you that there is a negative sign in the formula. So that means when I pull h out of the problem for my vertex, I'm essentially pulling out the opposite of what I see. Now let's talk about that. Let's say in the function given, it says x minus 2. Well, the negative sign was already in the formula, right? So what is in place of h? What is our h value for this problem? 2, right? So we're looking at a negative 2, but we're pulling a positive 2 out. Okay, so you see what I'm saying? Now, let's say this was x plus 2. How did it go from a negative to a positive? The formula has a negative sign in it, but now our problem has a positive sign. How's the only way that's possible? A double negative, which means the h value that was plugged in was what? Negative 2. So you see what I mean when I say we're going to pull out the opposite of what we see for the h value. The k is going to be exactly what we see, but the h can be a little bit tricky if you're not careful. Now, write the equation for the axis of symmetry. This is where I'm still having people be confused. The axis of symmetry and the x-coordinate of the vertex are the exact same value. But here's the problem. When I ask you for the axis of symmetry, you can't just give me a value. You can't just say 2 or negative 5. Okay? The axis of symmetry is an equation. So let's go back in our minds. Last week we were graphing parabolas. Okay? We drew that axis of symmetry straight through the vertex. What kind of a line was it? Vertical, right? And vertical lines go through which axis? Every single time, right? So when I ask you to write the equation of the axis of symmetry, it's always going to be x equals some value. Now, if you don't remember that yet, put it in your notes. Okay? The axis of symmetry has to be an equation because it's a line every single time. So the value is what is easy to find. Okay? The value of the axis of symmetry and the x-coordinate of the vertex are going to be exactly the same. You just can't forget the axis of symmetry is an equation. All right, now, again, let's practice it. Example number 2, find the vertex and the axis of symmetry of the graph of the function. Now, the best thing I can do for you right now is I can write above the given function the formula. So f of x equals a times x minus h squared plus k. Now, what do you see in place of h? 1. However, that is plus 1. So be careful. When you're pulling out the h coordinate, you have to pull out the opposite of what you see. So if we see a plus 1, what is the actual value of h? Negative 1. All right. Now look for k. Do you see any value where k should be? No. So what number represents nothing? 0. So there is a y or a k coordinate. It's just 0. So the vertex of this problem is negative 1, 0. Negative 1, 0. Now, did we talk about what the vertex actually is? Who can give me a definition of a vertex? We learned this also last week in 8.1. Right off the bat, I taught you what a vertex was. Look back if you can't remember. It's the highest or the lowest point on your parabola. So that's why it's always going to be an ordered pair, because it's a point. It's either the highest point or the lowest point based on whether your graph opens up or down. Now, we also need the axis of symmetry. So we've got the vertex for letter A. What's the axis of symmetry? X equals. Remember, it can't just be a value. It has to be an equation, and it's always x equals something. And it's x equals -1 because the x coordinate and the axis of symmetry have the exact same value. Now, take about 30 seconds with the people at your table and figure out letter B. All right, again, above letter B, I'm going to put the formula. Remember, f of x and y are the same thing, but it equals a times x minus h squared plus k. This is the vertex form. So what is the vertex of this function? 4 what? All right, let's talk about it. The formula already has the minus sign in it, so we are looking at -4. We pull out the opposite of what we see. So you pull out a +4, and of course, again, there's no value there for k, so the k is 0. So the ordered pair is 4, 0. How many of you got, by show of hands, how many of you got 4, 0? Awesome. All right, Emma, what is the axis of symmetry for this one? X equals 4. Okay, remember, it's an equation. Always x equals because it's a horizontal, it's a vertical line. So it's always going to be x equals, and the x coordinate of your vertex and the axis of symmetry are the same value. All right, how many of you got x equals 4 as your axis of symmetry? Awesome. Now, the next set of instructions in example 3 ask us to compare the equation to the equation of f of x equals x squared. Now, I want to insert this. Your homework tonight is going to ask you on a couple of these to graph the function, then compare, okay? You are going to graph in your homework because you do need to continue practicing graphing. It's Desmos. You're using Desmos. The only thing that's not going to show up on Desmos when you plug in the equation that must be included in your graph is the axis of symmetry. So don't forget that tonight when you're graphing. But once you've graphed the function, then to compare the two functions, you can just use the equations, all right? But let's talk about this equation that we keep. Why do we keep comparing our new functions to f of x equals x squared? What do we call this f of x equals x squared? The parent function, all right? It's the parent function because it is the function that we are transforming. We're moving up, down, over, we're flipping it, we're stretching it, we're shrinking it. So this is called the parent function. And if you still don't know that, please also add that to your notes. Okay, that's a really good quiz or test question. What is the parent function? It's f of x equals x squared. Now, it's important that you understand that because when I go to look at letter A, I want to identify the parent function first. So I can see right here's my x and right here's my squared. So that kind of makes it easier for me to notice what they've done to the function. How many things, transformations, have they done to this problem? 2. All right, what are they? We've got the 2 right here and we've got the +5 right here. So let's start with the 2 because it's at the beginning of the problem. Grab those cheat sheets and ask yourselves, what are they doing with 2? They're multiplying it. And are they multiplying it by f of x or just x? This is the tricky part. What are they multiplying 2 by? F of x. It's outside the parentheses. They're multiplying 2 by f of x. So does that make, well, first of all, if we're multiplying, what type of transformation is that?
Vertical.
That's not the transformation. That's a stretch or a shrink. All right? If they are multiplying by something, that is a stretch or a shrink. Now, if they are multiplying f of x by something, that makes it what? Vertical or horizontal? That makes it vertical. So that's the first part we're going to write down. This is definitely vertical. But now we got to figure out A. Does A fall into the greater than 1 category or into the between 0 and 1 category? 2 is definitely greater than 1. So that makes this a vertical stretch. Now, we like vertical stretches and shrinks because it's by a factor of what we see. What is right there in the problem?
2.
So by a factor of 2. Awesome. Now, the +5. What type of transformation adds something to the problem? A translation. Okay, good. So the next question is, are they adding something to f of x or to just x?
Just x.
Good. This time they're in parentheses. So they're just adding the 5 to x. So is that vertical or is that horizontal?
Horizontal.
All right, that is a horizontal translation. Horizontal translation. Now, be careful about the direction, because naturally we're thinking if they're adding 5, it would be natural to think they're going to the right, right? Because on the x-axis, going right is positive. But it's actually the opposite of what you would think. So this is a horizontal translation. What direction? Left. How many units? 5 units. Very good. Very good. So these are my 2 transformations for this first problem. Let's look at letter B. Again, let's find that parent function, because that'll help me to see what they are doing to this function. How many things, how many transformations have they done to this function? 2. Again, what are they? Okay, we got a negative sign right here and a -2. All right, good. Let's start with the sign. Which type of transformation has a sign change? A reflection. All right. But are they changing the sign of f of x or just x? This one's f of x also, because it's outside the parentheses. So if they've changed f of x, it's a reflection across which axis? The x-axis. Very good. All right, now they're subtracting 2. What type of transformation has you subtracting something? Okay, a translation. So are they subtracting 2 from f of x or just x? So that is a horizontal translation again. But again, naturally we see -2, we're thinking left, but it's actually a horizontal translation right. How many units? Awesome. And there's your 2 transformations for that function. Now for letter C, I did not make you copy the graph, but let's talk about the 2 graphs we're looking at. All right, we've got the f of x equals x squared, which is the black parabola, and then we have g of x equals 1/2 times x minus 4 squared, which is the blue parabola. Which one is the parent function? Okay, the black parabola, the f of x equals x squared. So when we are trying to figure out the transformations, we are looking right here at g of x equals 1/2 times x minus 4 squared. So write that function down next to letter C in your notes. Okay, I didn't make you draw the graph, but I want you to write down the function that we are dealing with right now. All right. Now, some of you would be able to look at that graph and tell right away what type of transformations have happened. Okay. Others of you are getting used to looking at the function itself, the equation. All right. So really, when you have the graph in front of you, you can look at the graph and try to figure it out if you want, or you can do what we've been doing, which is what we're going to do right now together. All right. We're going to find that parent function, which is right here. So that makes it easy to see how many transformations have they done to this graph? 2. All right. What have they done to this graph? We've got a 1/2 and a -4. All right. Let's start with the 1/2. What are they doing with 1/2? Multiplying it. So what type of transformation is that? Stretch or shrink. All right, awesome. Are they multiplying f of x or just x?
F of x.
F of x, which Claire makes this what kind of a stretch or shrink?
Vertical.
Okay, it's vertical. And Claire, what category does this 1/2 fall into? Is it greater than 1 or is it between 0 and 1? So is it a stretch or a shrink if it falls between 0 and 1? It's a shrink. By a factor of? Claire, by a factor of what? 1/2. Perfect. Like I said, we really like these vertical stretches and shrinks because it's by a factor of exactly what we see. All right. If it's horizontal, it gets a little trickier. All right. Now, the -4. If they are subtracting something from this function, Esther, what type of a transformation is that? Translation. All right. And are they subtracting from f of x or from just x? So that makes it a horizontal translation. Good. This is a horizontal translation. What direction, Esther? All right. We see negative and think naturally the left, but it's actually the right. How many units? 4 units. And these are the 2 transformations that have happened to this problem. Okay? Now again, some of you may be able to look at that graph and you can see it shifted to the right 4 units. Okay? I think the shifts, the translations are easy to see on the graphs. What gets a little bit more difficult is those shrinks and those stretches. All right? So that's why you've got to be able to interpret the equation along with the graph. All right? But that is lesson 8.4.